Hi everyone, this is Miss Miller. I wanted to talk you through the extension predicting products using reaction types. I wanted to talk through this first example to kind of show you my thought process. Hopefully this will help you on the following examples. So this first example, we are given magnesium chloride and sodium hydroxide as our reactants. That's MgCl2 plus NaOH. And one really key thing here is over here in the identifying parts of molecules, we see that OH is kind of a substructure. So you can imagine that there are parentheses around OH, although we don't write them because there's no subscript to put on the outside of those parentheses. So we really have Mg, Cl2, Na, and OH. We have 4 parts going on here. So this automatically tells me that this is going to be a double replacement reaction. Single replacement would simply have 3 parts. Double replacement, you're seeing all 4 of those. So let's identify those molecules. A is the one that always comes first, B comes second, C comes third, and remember OH comes together, that comes as D. So we have A, B, C, and D, but before I start trying to predict the products, it's going to be really important that I make sure to include my charges. For example, we're already told that OH comes with a negative charge. Now remember, that means an invisible 1 is there, so this is a -1 charge. This is an anion. So we need to make sure that we are also identifying the charges of Mg, Cl, and Na. To do this, we're going to use our periodic table to help. Let's actually start with the NaOH molecule. So I'm going to zoom into NaOH. I'm going to look at the charges of Na and OH. I already know that OH is -1. That's what I'm given. Let's head to the periodic table and check Na. So here's Na, sodium. Notice that sodium is in group 1, meaning it has 1 valence electron. So to be happy and full, it wants to give away that 1 valence electron, becoming a +1 charge. So I'm going to add that. My Na is going to have a +1 charge right there. Let me zoom in for you. I'm really glad that this is the case because my Na has a +1 charge, my OH has a -1 charge, and this makes the overall molecule, NaOH, neutral. This is excellent because the definition of a molecule is an overall neutral group of atoms. Okay, so let's shift our focus. Let's go up to MgCl. I'm going to focus on this molecule right here, trying to determine the charges of Mg and Cl. I'll head back to my periodic table to gather some evidence. Mg I see is in group 2. Group 2 telling me that there are 2 valence electrons. So Mg would really want to give away those electrons in order to be happy and full. It would become a +2 cation, +2 charge. Cl, though, is over in group 17, telling me it has 7 valence electrons. It really wants to take on 1 charge in order to be happy and full. So it would become -1. So let me record those charges here. My Mg wants to become +2, and my Cl becomes a -1. Let's do a quick check that our overall molecule is indeed neutral. If my Mg has a charge of a 2+, and my Cl has a charge of 1-, but I have 2 Cl atoms, well, yeah, overall this is going to be neutral. Excellent. So we have now determined that this is double replacement reaction. We have identified the parts A, B, C, and D. Now we are going to come up with the products. We're going to predict the products for this reaction. Now I know for a double replacement reaction, we are looking at AB plus CD yields AD plus CB. So I'm going to use that to help me out here. AD plus CB must be my products. Sorry, that's a lowercase l. But we need to double check that all of our product molecules are indeed neutral as well. So let's do a double check. I'll focus in on MgOH first. Magnesium hydroxide. Okay, magnesium comes with a 2+ charge, and OH comes with a minus or a 1- charge. I know that from my identifying parts column. So in order to make this overall neutral, I'm going to need 2 OHs. So I'm going to add a subscript onto my OH. It'll look like this. Oops, didn't mean to delete that. I'm going to add around the parentheses a 2. That way my Mg with a 2+ charge and my OH with a -1 charge doubled. Overall, that molecule is neutral. And I'm going to try to do the same thing for Na and Cl. Here's my next focus. Na comes with a positive charge, or a 1+. Cl comes with a negative charge, or 1-. Hey, this one's already neutral. So I'm nice and happy with no subscripts over here. So our last step is going to be writing out the completed balanced reaction. I'm going to write it below just because I'm running out of room. So I'm going to take my reactants that you see in the first column, yielding my products that I just determined in this column, and remembering that the only thing that I can do is add coefficients as I balance an equation. So I'm going to leave some blanks there for me to remind me that's where I'm going to change, if I need to. I always come back to my atom inventory. That's how I start every balancing equation. And I'll list them in the same order over here in my products. Counting them up. I notice I have a few things that I need to change here, so I'll start to play with my coefficients. Always updating that atom inventory afterwards. And as a quick check, I am showing conservation of mass for each of these types of atoms. So my final answer would be MgCl2 plus 2NaOH yields MgOH2 plus 2NaCl. And of course, I would be trying to fit it into that tiny box. So to recap what we're doing, we're first looking at the reactants and deciding if this is single or double replacement. Then we're identifying the parts A, B, C, and D, but also in that step, making sure that we have the charges written, those little numbers up there, thinking through using our knowledge of bonding and the periodic table. That will then help us write the products using our A, B, C, D parts, but also making sure that in our products that all of our overall molecules are still neutral, so adding subscripts as needed. And then the final part, good old balancing the reaction. I hope this video helps. Happy practicing!